Andy, I've heard of this pole shifting, haven't we? And explain that to us.
So how often does this event tend to occur?
Right.
So it's good that you said tend to occur because it's not regular.
Yeah.
So we can't predict when the next one's going to happen for sure until it's nearly on us, right? But
is that dangerous?
I'll come back to that, but
if you can't predict it, that sounds pretty dangerous.
But it's quite slow, so we would get some warning when it happened. Might be able to adapt. Yeah. So the last one happened 780,000 years ago.
Right.
But on average, in the last 10 million years or so, they've happened about 4 times per million years. Right. So you could say we're well overdue. But that doesn't mean that one's going to happen very soon. It could be millions of years before the next one happens. Because it's just a stochastic process. Just don't know.
So has there ever been? I suppose this is a proper mad question. Of like when it collapses, that it rebuilds in the correct way. Like so, for example, every time it collapses, does it always flip, or can it rebuild the correct way?
In fact, more often than not, it comes back in the same polarity it was. It recovers. So we call those events excursions.
Right,
magnetic excursions. So there, the magnetic pole goes a long way away from the geographic pole. So more than 45 degrees. So it's near the equator somewhere. Yeah. But then it recovers again. And those tend to be a bit short-lived events. So they might only big one of those might only last a few thousand years, whereas for your full reversal to happen, that can take more like 10,000 years for that to happen.
To fully
reverse, to go from being stable, normal to stable.
And how long did you say it takes to go from the equator back up to where it was originally?
Well, so the field becomes very complex at these times. So it's no longer well described by a simple bar magnet, which is how we tend to think about it.
With the two things coming like
exactly
round.
the flux lines, going from pole to pole. So that's not a bad description for the field today. But at times when it's undergoing these excursions or reversal transitions, it's much more complex than that. So it's multipolar, and you get So that means that the pole that you're closest to you that you're seeing might move very quickly indeed. So we've had arguments that there's from high resolution lake sediments and stuff. Had arguments that you can see it happening within decades. The kind of this thing moving over, but that will probably be in just that one place. Where they've caught it, and other places would not see such rapid changes.
That's insane.
Wow.
So I know. So basically, I was just going to ask the question you referred to
go on.
before. What are the implicit dangers now? Because obviously, when this has happened in the past, we've not had things such as electricity and things like that. So what are and human life as we know it. So what are the dangers then? Should this happen today?
So the magnetic field does a big service for society in kind of shielding near Earth space from solar wind radiation. Okay, so we're talking about 10 Earth radii, so 60 odd thousand kilometers above the Earth's surface. You've got the magnetic field goes out and kind of dominates near Earth space in that side, and then it hits the magnetic field because it's coming from the sun, basically. And that magnetic field is being carried out on a stream of charged particles. Now, there's nasty stuff, these charged particles, There's, have you heard of solar storms and things like that? So if you had an astronaut that was outside the Earth's magnetic field, on the moon or something during a very big event, then that could potentially be lethal. The amount of radiation they received. So the magnetic field does a great job of
blocking out that.
Basically deflecting that radiation around the Earth.
And is that what causes the northern lights and
it
stuff?
It is. So that's the stuff coming in actually, because
right.
As you just said, those flux lines, they come into the Earth, right? So at high latitudes, the stuff it's like it gets stretched with an elastic band. This at the night side of the Earth, so the side away from the sun, and then it kind of pings back, and then these particles come in at high velocity, then hit the atmosphere. The atmosphere is a very good shield as well for the solar radiation, but that's what creates the the lighting effects that are aurora.
Wow, this is all. Sorry, there's loads of things in my life connecting all of a sudden.
So obviously, then the danger be once it flipped, the magnetic field isn't so much there or provides the same level of protection. Is that kind of the idea?
That's right, and well, it's worse than that maybe because it becomes all complex. So it might actually be driving the solar wind into the atmosphere at low latitudes as well. Which is where there's more life tends to be there. Now, so it's dangerous. We've got no evidence that life has suffered during these magnetic reversals in the past. Although someone did publish quite a controversial thing about Neanderthals going extinct in a quite high-profile paper, actually, because of the last big excursion, actually. So,
but weren't Neanderthals still about though, like 70,000?
Yeah, no, this is 40,000 years ago when the last big excursion happened.
Okay.
It's called the Le Champ excursion. But that's pretty controversial. In general, we don't see any records in the in the paleontological record of like life suffering during these reversals, because there's been a lot of them. 4 per million years. That's quite frequent in geological time. So life has found a way to adapt, and things like the birds that use this that use magnetic field for navigation. There's even been studies suggesting that they're able to recalibrate their internal magnetic compasses using the rising and the setting of the sun. So that they
birds are fascinating, man.
So they can.
Life's just fascinating in general, isn't it? Like how this type of stuff can just.
So what are the indicators, Andy, to a polar shift happening? Yeah,
so the field will get much weaker, and it has been getting weaker for the last few centuries. So yes, it would come, but it's still quite strong by geological standards. But it would keep on getting weaker, and there's a funny region of the Earth's surface, magnetic field at the moment, called the South Atlantic anomaly. And that's getting bigger at the moment, so that's kind of causing the global field to get weaker, that we've got this sort of anomalous, it's like the field's pointing in the wrong direction actually, down in at the core mantle boundary, and so that sort of anomalies like that would grow, and the field would just become more complicated, and
then you might get people saying we're on the edge of possibly moving into
this
phase of
this is all going to take, this probably all take centuries though, so it'll be played out in quite slow motion.
I'll be dead, I'd sound.
So.
It would be. There's no evidence that it causes major issues anyway.
There's a much more immediate related threat, which is the from solar storms themselves, because they essentially, if you can get this. If you get a very weird bundle of the sun's magnetic field coming out to the Earth's magnetic field, it can kind of open it up like a tin opener, and then all this magnetic flux can get inside, and you get aurora at very low latitudes. But you'd also get potentially a lot of damage to electrical infrastructure. So.
It's not going to be the ozone layer all over again, is it?
Well, in the 19th century, there's something called the Carrington event, right?
Yeah.
Which was a very big solar storm, and that did cause all these electrical problems in these telegraph lines, right? But that was something when technology was very, very nascent, right? If it happened now, it was predicted. This is a few years ago. I think we're better prepared now, but only 10 years ago or something, the National Academy of Sciences in the US predicted it would cost us like $1 trillion or something
to recover from such an event.
Yeah, because the problem is if it knocks out transformers, right, in the power grid, then they're not quickly replaced. So that means a big area of the grid goes down, and then you're trying to replace that, but you can't because you haven't got any power to power anything, So if it was a really big one, it could sort of cascade down and be very problematic.
The amount of social media flies who live on the phones who couldn't get it charged.
They just sit there with the phone, just looking at the screen, swiping up,
crying their eyes out.
Well, that's right. We're so reliant on it, and GPS, would potentially go down as well. You could have a lot of satellites losing function. So and GPS is used for all sorts of things in agriculture. For example, So it's so it did feel like 10 years ago when I was teaching this in a geohazards module at Liverpool, I felt like we weren't very prepared, and now it does feel like the governments are starting to
wise up to this maybe
and be ready. I mean, ultimately, you could be safe just by shutting down power grids just while the storm is going on,
because there's nothing active for it to kind of break, essentially.
Yeah, that's right. It's all about, it adds. So you've got power flowing through these lines, and they've got thresholds that the transformers can cope with. Right, you don't want to add anything massive to it. So if you just shut it down, then
you know what?
Then it's built-in protections.
I don't trust that the government's ready for that. And apparently we're ready for a pandemic, weren't we?
Yeah. Well, there is that.
We're ready. We're ready for the polar shift. 6 months later, we're all fucking locked down somewhere.
Tell you what, though,
the poles have shifted.
It is crazy, and how just like one day the sun could just go, right, you're not having telly anymore.
Yeah.
There we go.
No royal family this week.